All right. So in the previous part, we learned about how the foundation model work and what are the ways the model get the training data and things like that. In this part, we are going to explore how did the AI model get really better very quickly. Additionally, we are going to learn about what is the AI model weighting or weights and how does the AI model weight works. And we are going to conclude this part by learning how does the AI training process work. Enjoy.
But how do we actually? I mean, we often sort of go, okay, here, this model, it's a nice square box on the screen. It's got some lines going through it. That's great. How did we actually get to this area where it actually behaves in a way where it seems like it's able to understand and reason? So, as the model, we have a concept of parameters. So, what is actually happening when we're training, when a model is being trained, is a DNA, a neural network is being built using all of the data, the training data, and it is inferring relationships between concepts. So, if I say quick brown fox, the next word is likely to be jumps over the lazy dog, but it might also be the quick brown fox really likes to chase chickens. Those are going to be more heavily neural weighted relationships between concepts. And so as we build up this neural map of concepts and relationships, we these models start to exhibit emergent behavior, which means as the number of parameters, and these are the nodes in the neural network, as that increases, we start to see the models being able to do things that we didn't specifically train them to do.
Mm,
So we
mm,
didn't train a model to answer a question. We didn't train it to be able to write proverbs or poetry. But because it is seen and trained on so much data and inferred so
mm,
many relationships, these emergent behaviors appear.
mm. And how is the weighting happen? Weightage, like is it like something we have somebody who's training the model have to do, or the model
Nope.
itself will do the weightage?
The model, as the training process proceeds and evaluates all that data, the uh, the code that is used to train the model will look at all that data and continuously reweight the neural network,
Yeah.
rebalancing, reweighting, reassociating, and that's what takes so much time because
Mm,
creating a weight is really just a matrix dot product uh, multiplication between the two nodes on a neural network. But
yeah.
in this case, we don't really need to worry about that from
Yeah.
a how does that happen,
Yeah.
because we're just given the model weights.
Yeah.
If you're an engineer at OpenAI, yep, you definitely
Yeah.
need to worry about that. But
Yeah.
from a from a consumer perspective, you don't really have too much control over it. You just get
Right.
get access to the model.
So this weightage, does it mean like, okay, like you said, the first statement, to correlate two aspect and say that if it is right behavior, we give more weightage, and if it is wrong behavior, we reduce the weightage? Is that how it is?
That's it's Think of it more as the most likely next thing to
Yeah.
follow has a higher weight.
Oh, understood.
So if you were to say the sky is blue is
Yeah.
very much common. It's
Yeah.
going to have a very heavy weight because the sky is
Yeah.
usually blue.
Yeah.
Well, not in Auckland. But if you were to say the sky is um, filled with oxygen and nitrogen, now
Yeah.
that is less likely to be, so the weight will be lower, but
Right.
it is still possible.
Yeah.
What is really important though is as the model increases in the number of parameters or the number of nodes in the neural network,
Yeah.
the capability of the model increases.
Yeah.
Now, you will often see models referred to as, Phi 3 4B, which is 4 billion parameters. Now, that's actually a very capable model for a 4 billion parameter model.
Yeah.
If we compare that to, say, some of the larger models that are, coming out of OpenAI, we're talking hundreds of billions of parameters,
Wow.
750 billion parameters and up. So the capability of the model is often related to the number of parameters, but not completely. You can still, as we see with say 5.3, 4B models, those are still very capable models and able to do a lot of tasks. So model capability is mostly related to the number of parameters, but not completely.
Okay, awesome. A last question on weightage before I let you move on to the next
Yeah.
one is, um, these weightages, does it have any human interaction as well? Like any, like Facebook have human moderators sitting behind to moderate certain content, like, or is it always code based moderation?
That's a great question. So that talks about the training process a little. I glossed over the training process a little bit, and we said, we take the input data, the training data, we train the model, and then we produce an adaptation. That training process is actually multiple stages, and depending on the model, we have things like reinforced learning with human feedback, where the model is fine tuned to reduce certain behaviors and bad practices and improve the quality of the output. So there is some stages to do that. Those are often done with human assistance, but not completely done by humans. So there is a process, and as well, you can go and have a look at the details on how these models are fine tuned and reinforced learning is applied.
Yeah.
Those are well documented for certainly for the earlier models. There may not be as much documentation on the exact process that happens for, say, GPT-4o, the latest model from OpenAI. Um, but there is always a process where the behavior of the model is tuned and tweaked to ensure it is doing the right things. It's meeting its stated goals.
Okay, awesome. Thank you.
So yeah, so the parameters is an important value. It's not the only value to think about when you think about model capability.